Okay, this is a video I did the other day. It's out in a field. Now what you see are furrows going across the field. Now you notice the furrows in the back look like they're close to each other. It's because of my angle of view to the surface is more narrow back there as compared to up here where it's right close by me. I'm high above it. I got a good angle down to the furrow. Here my angle is more narrow, and so it becomes more difficult to see the space in between. Not to mention angular size, where the furrows here are more high. They look smaller and smaller and smaller at the distance. So that combined with compression and convergence, which is a natural way the eyes work. That's what forms horizons. When your angle is too low, it makes what's further back there have less angle to them, which makes them start to blend into each other, as you see there. Now you'll see in a second when I lower the camera, you're going to see that it becomes more blended in than it is even now. And it'll all start to appear as if it's a single line across my field of view. See how they're closing together? You can't see all separate rows back there. They all look like one row. When I lower, when I rise up, I have a better angle to them. Now, if I could go up even higher, I would see much more space between those, but you would still have compression, always at the far end of your angle of view. Now, here's just a quick little drawing, just to kind of show you how angle of view works. That's the boat. This is Tommy. Tommy can see the bottom of the boat because he has an angle over the waves to the bottom. You see that, Tommy? Now Tommy goes lower. Tommy is just at the surface of the waves. He's kind of down on his knees, looking over the waves, just seeing the top there. He sees this much of the boat. Why? Because he doesn't have a sufficient angle of view to look over the waves in front of the boat and see the bottom. Now, this boat, as it moves further, let's say this boat just keeps on going. I got a big, huge, long whiteboard. That boat will become smaller and smaller in angular size, and those waves will appear to cover more and more, not because they actually are. It's just that everything is getting more diminished in angular size. It just appears that it covers more when it actually doesn't. Okay, here's how horizons form. Here you're standing near the water. You have a steep angle down to it. That's your line of sight looking straight down at the water. You have plenty of angle. This little spot in here, there's plenty. You can see everything. There's sufficient angle for your eyes to resolve everything in there. The further out you look, your line of sight, the angle gets more and more narrow, but they're still sufficient up to when you get down here and look further out. There comes a point where your angle is here over the surface is too narrow. And your eyes can no longer differentiate between objects on the surface. If it was waves, all the waves will begin to look like one, and it'll just look like a horizontal line across your field of view, because you will no longer be able to see any difference in anything past that point and on and beyond. Now, of course, this is from a side view. Looking straight on, the surface would actually appear to slant up. And your eyes would meet that, and the narrow angle would look like it's up here in your vision, even though this is actually what is real. But your eyes make everything below your eye level goes upward towards it. Everything above your eye level goes down towards it. Or actually, everything above your eye level goes down towards the horizon. And everything below your eyes goes up to the horizon. The horizon is always just below your eye level. But it's basically at the same point. It's like conjoined twins. The eye level and the horizon will be side by side. Now, of course, if this person, which I call Tommy, went up here, his angle would be steeper going all to these points, and he would have to look much further in the distance to get to this little narrow point. That's all being done over a flat plane. That's how horizons form. It's where this point becomes too narrow and you can no longer see like individual waves. They all begin to blend like one, like in my earlier example on the board, where I showed how you can see to the bottom of the boat if you have a steeper angle over the waves. It's the same thing. Now we got to remember also, the further you look out here, if you had waves, they look more and more smaller and diminished in size, as well as closer together, like you saw in the first part of my video in the field with the furrows. Once you get to a point where your angle over that surface is too narrow, all those furrows look like they blend into one. This is how horizons form. This is so simple. Has nothing to do with curvature. It's just the way your eyes work. Convergence and compression and diminished sizes and distance, or diminished sizes with distance. And where the angle of view is always more narrow down here than it is right below you. In the distance, that angle changes. This is so simple. The geometry of perspective is the imaginary curve.